All right, so my name is Tony Burke. And today I'd like to talk about something that's been kind of annoying me lately. And and I'm annoyed not because of, well, you know how some people mean your, as in you are, is a contraction, and then they say or they write your. Now, it's a fairly pedantic point, and typically when someone makes that mistake, you can figure out what they mean. But once you figure out how to fix this mistake on yourself, every time you see it, it becomes really annoying. Uh, and fairly inconsequential, but it's fairly annoying. But it becomes fairly annoying. Now, I'm starting to see something like that with the term LACP and link aggregation. I see a lot of people saying that you should set up LACP between these two switches or set up LACP between this host and this switch and whatnot. And they don't really mean LACP. What they're really talking about is link aggregation. And they are two very different things. Now, in the end, we probably get what they're talking about. But my concern is it means that they're not really understanding what the technology is that's underlying it. Although that could not be the case. It could be just they're using the colloquialism or idiomism or whatever it is. But it bothers me every time I see it. So let's talk about that. What the difference is. So the title of this talk is you say LACP, but you really mean link aggregation or link aggregation group. A technology a while ago was ratified by the IEEE. And this technology is called link aggregation. It was in the 802.3 AD working group. It has been moved to 802.1AX hyphen 2008, and now it's hyphen 2014. And what it is it's the technology that allows you to take multiple links and then bind them to as a single logical path. Because in Ethernet we have a rule, a commandment really, that says thou shalt not let there be more than one way to get anywhere. That's why we have spanning tree. A lot of people say spanning tree loops, but they really mean bridging loops. A spanning tree doesn't loop. A spanning tree prevents loops. And we can have spanning tree do things like block all ports, as it did in 802.d. But when if a bridging loop occurs, it means we've got bum traffic, broadcast unknown unicast, multicast, etc., going crazy. And one of the ways that we can get around this is by doing link aggregation, which is tying multiple links into a single layer 2 logical path. We call this link aggregation. A single instance of this is called LAG, link aggregation group. In the Cisco realm, they have two names for this. One is called Ether channel and one is called port channel. Ether channel is what they do in the Catalyst world, and port channel is what they call it in the Nexus world. Now, there is no difference between Ether channel, port channel, and link aggregation. They're all the same. It is a standard, not a protocol. A standard is things like, if I'm driving on the highway, I drive on the right side, and everyone drives on the right side. That way no one collides head on. That's the standard in the United States and Europe, or most of Europe rather. And for example, in England, Ireland, and Hong Kong, they drive on the left side. That's a standard there. No communication needs to happen between me and the other drivers. We just know that that's the standard in that country. So no communication needs to happen between these two devices. Let's say this is switch 1 and this is switch 2. Switch 1 has packets destined for switch 2, and it divides up traffic across those links, and it uses one of any number of load balancing mechanisms. The standard does not depict which load balancing mechanism you have. And the standard doesn't even encapsulate the standard doesn't even say another golden rule of networking is thou shalt deliver packets in order. So in order to deliver packets in order, we have to make sure that all packets of a certain type, of a certain flow, go over the same link. Otherwise, if we divide up packets from the same flow across multiple links, I can get held up in the ingress or egress buffers, and packets will arrive out of order. That's very bad. So what we do is we do some sort of hashing mechanism typically, so that all of the header values, or one or more of the header values, layer 2, layer 3, layer 4, get hashed into a binary hash, and it gets put into a table, gets put into a bucket, which gets deposited into a link. And that works okay. And the interesting thing that a lot of people don't realize is that we can use a different method. For example, we can do source destination MAC address going this way, and the other way we can use a completely different method. We can use source destination IP on the other way. And it doesn't matter because the standard allows for that. These are logical, these 4 links are one logical path. They get, they're treated as the same destination, and they get reassembled on the far end. So you can actually have 2 separate load balancing mechanisms going in each direction. Switch 2 has no influence whatsoever on the mechanism that switch 1 uses. And generally speaking, it doesn't matter. It's perfectly fine to have different hashing mechanisms going both ways. And oftentimes that's the case, especially if you have 2 different vendors. For example, if I plug a ESXi host into a switch or a pair of switches, and I select link aggregation, which is basically hashing the source IP address, that's one hashing mechanism. The switches might default to doing a hash of the source and destination IP address and layer 4 address. And that's a different method of hashing. That's perfectly fine in most cases. You may have a situation where you need congruence, which means you need to use the same hashing mechanism going backwards and forwards, because you may have some device at each of one of these locations that is looking for the same flows. In that case, you would need to have the same flows going in each direction. But that's pretty rare and pretty difficult to do, because just because two devices use the same hashing mechanism, they might order the interfaces in a different way, and you still end up having one flow going over this way and one flow going over that way, even though you have the same hashing mechanism. So the only real way to guarantee hashing mechanisms are identical is to use the same device on both locations with the same code, the same hardware, and the same sort of ordering for the interfaces. So and that's not impossible, but generally more rare. So forget about that. As an option to link aggregation, we have the ability to use a protocol. Now, back in the day when Cisco was starting to do this, they had their own protocol called PAGP, Port Aggregating Group Protocol. And that is a Cisco proprietary protocol. And the IEEE came up with a similar protocol called LACP. Now, they both basically do the same thing. What they do is they send these PDUs, these little messages going in each direction. And what we're looking for is the response. So that switch 2 sends a PDU over to switch 1. Switch 1 says, yeah, I'm switch 1. And we're looking for the same message on all links. And basically the only thing that LACP does is it says, well, not the only thing, pretty much the major thing that it does is it makes sure that all of my links on switch 2 are plugged into switch 1 and vice versa. If I didn't have LACP, I could certainly do a link aggregation group. There's no problem with that. But the problem comes in with misconfigurations. In a big data center, you may have a situation where you just miscable something. So you can think of LACP as a miscabling protocol. So let's say I plug switch 2 instead of into switch 1 for this 4th link here. I accidentally plug it into, I don't know, say a coffee maker. Get rid of that lag thing there. So I accidentally plug it into a coffee maker. And let's pretend for whatever reason this coffee maker has like a 10 gig interface. It's a very advanced coffee maker. Without LACP, we call that a static lag. With a static lag, as soon as a link light comes up, boom, you're out to the races. Packets are being sent via the hashing mechanism. And some of them are going to be sent down that link and end up in the coffee maker. The coffee maker is just going to drop them, get overwhelmed, whatever. The packets aren't going to make it to their destination. So 1/4 of the paths that you have gets black holed. So in order to avoid that, we can use LACP. And if LACP detected that we were plugged into, 3 of the links were plugged into switch 1 and 1 of the link was plugged into a coffee maker, it would actually down that link and not send any traffic, and then send traffic over the 3 links. And that's the behavior you would typically want for that kind of misconfiguration. And that's what LACP does. LACP. And that's what also PAGP does. But we typically don't see PAGP much anymore in the data center because there's an open standard for that, and we tend to use that instead. Some of the older iOS hardware does support PAGP. I work in primarily the data center, and I haven't seen PAGP in many, many years. So when you say LACP, you really mean link aggregation. LACP is an optional part of link aggregation. LACP has no influence on the hashing mechanism used to divide up traffic between the 2 links. Now I say that, but there's a little asterisk to that statement. In 802.1ax 2014, there is a little known, and as far as I can tell, unused TLV, type link variable, that the 2 switches can communicate to represent the hashing mechanism that they use. Ostensibly so that they can sync up and use the same hashing mechanism in both directions. However, I have not seen that implemented by any vendor. I actually talked to the person who proposed this to the IEEE. He works at ZTE in China, and it was ratified into 802.1ax-2014. But even ZTE, the hardware, I cannot see anyone that's using that particular bit of hardware. We may see it in the future, I don't know. But as far as I can tell, no one is using that particular TLV. So my original statement stands, at least in implementation. In practice, you cannot influence the direction of traffic that the other switch, or the load balancing mechanism that the other switch uses. So hope that clears things up, and just keep that in mind. When you say LACP, you probably mean link aggregation. It's a colloquial term or idiomatic term, and we typically understand what you mean. But just for the efforts of precision, try to keep that in mind when you're talking about it and use the right term. I hope that helps, and thank you for watching.